I'm grateful you joined tonight. 66 million years ago, a creature walked the earth so powerful, so perfectly adapted, that its very name still makes us pause. Tyrannosaurus rex, the tyrant lizard king. Tonight, you'll discover the truth behind this ancient predator and understand why the most famous dinosaur ever known still lives in our imagination. Welcome to the Sleepy Safari. Now settle in. You're resting in a world once ruled by giants, where forests shook with footsteps, where rivers ran beneath creatures that stood 3 stories tall, where T.rex hunted beneath skies we can barely imagine. We'll uncover 100 sleepy facts about this lost legend, from the moment it hatched from an egg to the final T.rex that ever lived, to the fossilized bones that let us see it clearly across the gulf of deep time. These peaceful journeys through time and legend create a bridge between past and present. Sharing these stories helps other curious minds discover this sanctuary and brings us closer to protect the memory of creatures lost and imagined. One sleepy soul at a time. We're grateful you're here. Let yourself settle completely here. Feel your jaw unclench, your breath deepen naturally. You can let these ancient stories drift past without holding them. Sense that soothing heaviness enveloping you, like time itself slowing down. Boundaries between past and present dissolving into the peaceful fog of sleep. Close your eyes and breathe deeply. You're standing where ancient giants once walked beneath forgotten skies. Let your mind journey through deep time. And now we begin. Tyrannosaurus rex lived approximately 68 to 66 million years ago, during the very end of the Cretaceous period, in what is now Western North America. This was a time when the continents looked different than today. North America was split by a vast inland sea, and T.rex roamed the western landmass, called Laramidia. The climate was warmer, wetter, more tropical than the Montana and Wyoming Badlands where we find its fossils now. Rex appeared near the end of the age of dinosaurs, just a few million years before the asteroid impact that would change everything. It was the final, most powerful predator of its lineage. Scientists estimate T.rex existed as a species for only about 2 to 3 million years. Brief, in geological terms, but long enough to become legend. The name Tyrannosaurus rex means tyrant lizard king in Latin and Greek. It was named in 1905 by paleontologist Henry Fairfield Osborn, who recognized that this creature deserved a name reflecting its dominance. Tyrannosaurus refers to its tyrannical, ruling nature, a predator at the top of the food chain. Rex means king, and that's exactly what it was, the apex predator of its ecosystem, feared by every creature that shared its world. No other dinosaur from its time and place could challenge an adult T.rex. The name captured imaginations immediately, and over a century later, it remains the most famous dinosaur ever discovered. Sometimes the first name given is the perfect name. An adult Tyrannosaurus rex could reach lengths of about 40 feet from nose to tail, standing roughly 12 to 13 feet tall at the hips. That's about as long as a school bus and as tall as a single-story building. Its massive skull alone measured up to 5 feet long, housing a brain larger than most dinosaurs and jaws capable of crushing bone. Weight estimates based on the most complete skeletons suggest T.rex weighed between 8 and 10 tons. roughly the weight of an adult African elephant. But unlike an elephant, which moves slowly and peacefully, this mass was built for power and speed, muscle and bone designed to hunt. Standing next to a full-size T.rex skeleton in a museum, humans look tiny. We are, too. Rex had one of the most powerful bites of any land animal that ever lived. Biomechanical studies using multi-body dynamics models estimate its bite force at 35,000 to 57,000 newtons, roughly 8,000 to 12,800 pounds of pressure at a single tooth. That's approximately 3 to 4 times stronger than a modern saltwater crocodile, and far beyond what any lion or tiger can produce. To time, Rex could bite through bone like we bite through a carrot. Its teeth could punch through thick skeletal structures, accessing the nutritious marrow inside its prey's bones. This wasn't just a meat eater. It was a bone crusher, able to extract nutrients few other predators could reach. Few creatures in Earth's history possessed such devastating power. And Rex teeth were not all the same size or shape. At the front of its mouth, it had D-shaped, thick incisors designed for gripping and tearing. Along the sides, its teeth were massive, serrated, banana-shaped blades up to 12 inches long, including the root. The serrations worked like steak knives, sawing through flesh and bone. When a tooth broke, and they did, often, a new one grew in to replace it. Rex constantly shed and regrew teeth throughout its life, a conveyor belt of weaponry. Paleontologists have found isolated T.rex teeth scattered across fossil sites, evidence of violent feeding, of struggles, of life lived at the edge of hunger and survival. Each tooth tells a story. The arms of Tyrannosaurus rex were famously small, only about 3 feet long, comically tiny compared to its massive body and head. For decades, scientists puzzled over why such a powerful predator had such reduced forelimbs. Recent research suggests the arms weren't useless. They were incredibly strong, with large muscle attachment points, and each hand had 2 clawed fingers capable of gripping with surprising force. One hypothesis is that T.rex used its arms to grip prey or push itself up from a resting position. Another idea is that the arms helped during mating, holding onto a partner during reproduction. As T.rex evolved, its skull and jaws became its primary weapons, and arms became less important. Evolution doesn't keep what it doesn't need. Tyrannosaurus rex had highly developed vision, potentially more refined than most modern predators. Studies of T.rex skull anatomy, published in journals like Science and Nature, show that its eyes faced forward, giving it binocular vision, depth perception similar to a hawk or an owl. This allowed it to judge distances accurately, critical for a predator that needed to ambush or chase fast-moving prey. Its eye sockets were large, suggesting big eyes adapted for seeing in low light. Some researchers believe T.rex may have hunted at dawn or dusk, using its vision advantage when other dinosaurs couldn't see as well. It didn't hunt blind or stupid. It saw you clearly, calculated your distance, and struck with precision. Rex likely had a remarkable sense of smell. CT scans of T.rex skulls reveal large olfactory bulbs, the part of the brain responsible for processing scent. In fact, T.rex had one of the largest olfactory bulbs relative to brain size of any dinosaur studied. This suggests it could detect carrion from miles away, track wounded prey, or locate hidden nests. Smell might have been even more important than vision for finding food across vast territories. Modern scavengers like vultures rely heavily on scent, and T.rex may have done the same, whether it was an active hunter, a scavenger, or both. And evidence suggests it was both. Its nose led the way through ancient forests, following invisible trails of blood and decay. The debate over whether T.rex was primarily a predator or a scavenger lasted for decades, but current evidence strongly suggests it was both. Fossilized bite marks on Triceratops and Edmontosaurus bones showed T.rex attacked living prey. Some wounds healed, meaning the prey survived the initial attack. Other bones show feeding marks from scavenging already dead animals. A 2023 study analyzing T.rex tooth wear patterns concluded it fed, opportunistically hunting when it could, scavenging when it couldn't. This makes ecological sense. Large predators today, like lions and hyenas, do the same. Hunting takes energy. Scavenging is efficient. T.rex was smart enough to take advantage of whatever food source it found. Pride didn't matter. Only survival did. No. Rex grew incredibly fast during adolescence, gaining up to 4 pounds per day during its teenage growth spurt. By studying growth rings in fossilized bones, similar to counting tree rings, paleontologists determined that T.rex reached full adult size around age 18 to 20. Juvenile T.rex, sometimes called Jane or Scotty, depending on the specimen, looked very different from adults. They were lighter, faster, with longer legs relative to body size, probably hunting smaller, quicker prey. As they matured, they bulked up. Their skulls became massive, and they transitioned from speed to pure crushing power. This means a T.rex ecosystem had multiple size classes hunting different prey, young ones chasing, old ones ambushing, a single species filling multiple predator roles. Tyrannosaurus rex was likely covered in scales, not feathers, at least as an adult. This is based on preserved skin impressions from several T.rex specimens, including parts of the tail, neck, and pelvis, showing pebbly, reptilian scales. However, its earlier relatives and close cousins, like Utyrannus, had feathers, and juvenile T.rex may have had some fuzzy protofeather covering that was lost as they grew. The current consensus, based on 2017 and 2024 studies, is that adult T.rex was mostly scaly, possibly to help regulate body temperature in the warm, late Cretaceous climate. A giant body doesn't need insulation. It needs cooling. Feathers would have been a disadvantage. Sometimes, evolution takes things away. Only about 50 partial or complete Tyrannosaurus rex skeletons have been discovered, making it relatively rare in the fossil record despite its fame. The most complete specimen, known as Sue, was discovered in South Dakota in 1990 and is now displayed at the Field Museum in Chicago. Sue is about 90% complete, a remarkably well-preserved specimen. Other famous specimens include Scotty from Canada, which might have been the largest T.rex ever, and Stan, whose skeleton was auctioned in 2020 for $31.8 million. Each skeleton teaches us something new. Sue revealed evidence of infections and injuries. Scotty showed bite marks from another T.rex. Every fossil is a frozen moment, a single life preserved across unimaginable time. Descender. Rex lived in what is now Montana, Wyoming, North Dakota, South Dakota, and parts of Canada. But 68 million years ago, this landscape was vastly different. It was warm and humid, with rivers, floodplains, and forests of conifers, ferns, and flowering plants that were just beginning to dominate. Sea levels were higher, and an inland sea called the Western Interior Seaway divided North America down the middle. T.rex lived on the western side, called Laramidia, a long, narrow landmass stretching from Alaska to Mexico. The eastern side, Appalachia, had its own dinosaurs, but none as large or powerful as T.rex. Geography shaped evolution, and T.rex was the king of its isolated kingdom. T.rex shared its world with many other dinosaurs, some of which were its prey, others its competitors. Triceratops, the three-horned herbivore, was one of its primary prey species. Fossil evidence shows T.rex bite marks on Triceratops' skulls and bones, and healed wounds suggest some Triceratops survived encounters with T.rex and lived to tell the tale. In their way, Edmontosaurus, a large duck-billed dinosaur, was another common prey. Smaller predators like Dakotaraptor existed, but posed no threat to an adult T.rex. Ankylosaurus, the armored tank dinosaur, may have been too dangerous to attack. The late Cretaceous ecosystem was a complex web of hunter and hunted, and T.rex sat at the very top. Tyrannosaurus rex was a warm-blooded animal, or at least mesothermic, somewhere between cold-blooded reptiles and warm-blooded mammals. Analysis of bone growth rates, published in Science in 2014 and refined in 2023 studies, suggests T.rex had a metabolism faster than modern reptiles, but not as high as modern birds. This middle ground metabolism allowed it to be active hunters without needing to eat constantly like a mammal would. It could go longer between meals, important for an apex predator in an ecosystem where food wasn't always abundant. Rex's body temperature was regulated internally, but not at the energetic cost of true warm-bloodedness. It was efficient, like everything evolution perfected about this creature. 2. Rex had a tail that was critical to its balance and movement. Roughly half its body length was tail, acting as a counterbalance to its massive head and torso. When T.rex walked or ran, its tail stayed horizontal, shifting subtly to maintain equilibrium. Without that tail, the animal would topple forward under the weight of its skull. The tail was also muscular, with powerful tendons that stored energy, possibly helping with quick turns or sudden accelerations. Recent biomechanical models suggest T.rex could reach speeds of 12 to 17 miles per hour. Not as fast as earlier estimates, but still faster than most prey could sustain. It didn't need to be the fastest. It needed to be fast enough. The brain of Tyrannosaurus rex was larger than most other dinosaurs, especially in the regions controlling vision, smell, and coordination. CT scans of T. rex skulls show a well-developed cerebrum and large optic lobes, signs of a relatively intelligent predator. Compared to modern animals, too blithe, Rex wasn't as smart as a crow or a dolphin. But it was far from a mindless eating machine. It could learn, adapt, remember locations, and possibly even recognize individual prey or rivals. Intelligence in predators evolves because hunting requires strategy, timing, and problem-solving. A stupid predator starves. To purr, Rex survived for millions of years, which means it thought in its way, clearly enough to thrive. Fossilized footprints, called trackways, show that T. rex walked with a stride of about 12 to 15 feet. These tracks are rare but incredibly valuable, offering glimpses of behavior that bones alone can't provide. One famous trackway in New Mexico shows a large theropod, likely a T. rex relative, walking steadily across mudflats that later hardened into stone. The depth of the prints suggests immense weight pressing down with each step. Other trackways show evidence of changes in gait, slowing down, speeding up, turning. Each print is a moment frozen a dinosaur walking through an ordinary day, unaware it was creating a record that would last 66 million years. Movement becomes memory. Two-way. Rex likely had refined hearing. The structure of its inner ear, revealed through CT scans, suggests it could hear low-frequency sounds well below human hearing range. This would allow it to detect the rumbling footsteps of large herbivores or the distress calls of injured animals from great distances. Low-frequency sound travels farther through dense forest and over open plains, making it an ideal sense for a large predator. Modern elephants and whales use infrasound to communicate across miles. T. rex may have done something similar. Imagine the ancient world filled with sounds we can't hear. Deep rumblings, subsonic warnings, a language of giants spoken in frequencies lost to us now. Tyrannosaurus rex was not a dinosaur you could outrun, at least not for long. While its top speed is debated, recent studies using biomechanical modeling suggest T. rex could reach sustained speeds of 12 to 17 miles per hour, with short bursts potentially faster. Humans can sprint around 15 miles per hour for very short distances. But T. rex had stamina. We don't. Its legs were long, its stride efficient, and it could maintain pace over rough terrain where humans would stumble. More importantly, it didn't need to be faster than you. Just faster than you could run while tired, panicked, and lost in an unfamiliar forest. Predators win by outlasting, not outsprinting. The arms of T. rex, though small, were incredibly strong. Each arm could lift approximately 400 pounds. According to biomechanical estimates, the muscles attached to the shoulder and upper arm were powerful, and the two clawed hands were capable of gripping tightly. Some scientists propose T. rex used its arms to hold onto prey during feeding, preventing it from escaping while the jaws did the killing work. Others suggest the arms helped T. rex rise from a resting position, pushing against the ground to lift the front of its massive body. And there's the mating hypothesis that T.rex used its arms to grip a partner during reproduction, ensuring stability during the act. Small doesn't mean useless. Tyrannosaurus rex probably had keen night vision. Analysis of its eye structure suggests the presence of many rod cells, the photoreceptors responsible for low-light vision. Combined with its large eyes and forward-facing binocular vision, T.rex could likely see well in twilight or moonlit conditions. This would give it a hunting advantage during dawn and dusk, times when herbivores are active but visibility is reduced. Many modern predators are crepuscular, hunting at these in-between times, and T.rex may have followed the same strategy. Picture it, a shadowy forest at dusk, light fading, and a massive shape moving silently between trees. Eyes glinting, watching, waiting. T.rex had a complex system of air sacs connected to its respiratory system, similar to modern birds. These air sacs lightened the skull and allowed for efficient breathing, even during strenuous activity like running or fighting. CT scans reveal hollow spaces in the skull bones, evidence of these pneumatic structures. This adaptation helped reduce the weight of the massive head while maintaining strength. It also improved oxygen flow, supporting the high-energy demands of a large predator. Birds inherited this system from their dinosaur ancestors, and T.rex had it too. In this way, every bird you see today carries an echo of T.rex in its breath. Fossilized T.rex bones sometimes show evidence of disease and injury. The famous T.rex at the Field Museum, had signs of healed broken ribs, infected bones, and possible gout. Another specimen, known as Y-rex, showed bite marks on its skull from another T.rex. Some individuals lived with chronic infections, visible as lesions in the bone. These weren't creatures living easy lives. They fought, hunted, injured, and sometimes survived to heal. The fact that we find healed injuries tells us T.rex was resilient. It could endure pain, recover from wounds, and continue living. Life 66 million years ago was challenging, but also determined. Rex likely had a lifespan of around 28 to 30 years, based on growth ring analysis in fossilized bones. Few individuals reached maximum age. Most died younger, from injury, disease, starvation, or fights with rivals. The oldest known T.rex specimen, Scotty, was estimated to be about 30 years old when it died, showing signs of age-related wear and damage. For a creature that lived fast and intensely, 30 years was ancient. Compare that to modern large predators. Lions live around 15 years in the wild. Tigers about 10 to 15. Rex lived longer, fought harder, and left behind a legacy written in stone that outlasted kingdoms. Take a deep breath and feel this. You're standing on ground that once held the weight of giants. Beneath your feet, layers of earth press down on ancient bones, stones that were once alive, breathing, hunting. 66 million years ago, a T.rex walked here, felt the sun, heard the wind, fought to survive another day. You are also part of this living world, one creature among countless others, separated by time but connected through the same earth. the same carbon, the same struggle to exist. Your body knows these rhythms. The rhythm of life and death, the rhythm of breath, the rhythm of time moving forward. Always forward. You belong to this story. You always have. Now we continue through the deep time of giants. Rex babies hatched from eggs, likely in nests built by their parents. While no confirmed T.rex eggs have been found, closely related theropod dinosaurs like Oviraptor show evidence of brooding behavior, sitting on nests to protect eggs. Rex eggs would have been relatively large, perhaps the size of a football, with hard shells. Newly hatched T.rex, based on juvenile fossil evidence, were small, about the size of a turkey, covered in downy protofeathers for warmth. They grew rapidly, protected by adults until they could fend for themselves. Parental care in dinosaurs, once thought impossible, is now well documented. Even tyrants began as fragile, dependent hatchlings. Juvenile T.rex were built differently than adults, optimized for speed rather than power. They had longer legs relative to body size, lighter skulls, and more graceful builds. Young T.rex likely hunted smaller, faster prey, lizards, small mammals, young dinosaurs, while adults took down massive herbivores. This niche partitioning meant a T.rex population didn't compete with itself for food. Different ages hunted different prey. Fossil evidence from the Hell Creek Formation shows this size diversity clearly. As they aged, T.rex transformed from swift hunters into living battering rams. Evolution built flexibility into a single species. T.rex had no natural predators as an adult. Once fully grown, it was the apex predator of its ecosystem, with no challengers. However, juvenile and sub-adult T.rex faced threats from other large carnivores, and possibly even adult T.rex engaging in cannibalism. Bite marks on some T.rex fossils match the tooth spacing of other T.rex, suggesting intraspecific violence. Fights over territory, mates, or food. Cannibalism is common in modern apex predators like crocodiles and polar bears when resources are scarce. T.rex may have killed and eaten its own kind. Dominance has a dark side. The Hell Creek Formation in Montana and the Dakotas is the richest source of T.rex fossils in the world. This geological formation represents the last few million years of the Cretaceous period, right before the asteroid impact. Paleontologists flock here because the rock layers preserve an incredible snapshot of the final dinosaur ecosystems. Alongside T.rex, fossils of Triceratops, Edmontosaurus, and ancient crocodiles emerge from the eroding Badlands. Walking through Hell Creek today, with its striped cliffs and barren beauty, you're walking through a graveyard of giants, a place where the age of dinosaurs ended. To stay, Rex skin was likely gray, brown, or greenish, based on what we know about modern large animals and fossil pigment studies. While we haven't found pigment-preserving fossils of T.rex itself, related dinosaurs show evidence of earth tone coloration. Camouflage would have been advantageous for ambush hunting, blending into dappled forest light or shadowy riverbanks. Bold patterns like stripes or spots are possible, seen in modern predators. A 2022 study suggested T.rex might have had countershading darker on top, lighter below, breaking up its outline. We imagine it dramatically colored, but reality was probably subtler. To tote, Rex likely had a keen sense of spatial memory, able to remember locations of water sources, prey migration routes, and territorial boundaries. Large brains in predators evolved partly for navigation. Modern wolves and big cats remember vast territories, sometimes hundreds of square miles. To T.rex probably did the same, moving through its range with purpose, returning to productive hunting grounds seasonally. Memory allowed it to anticipate prey behavior, plan ambushes, and avoid competitors. Intelligence isn't just problem-solving, it's remembering what worked before and applying that knowledge again. Fossilized T.rex dung, called coprolites, has been discovered and analyzed. One famous coprolite found in Saskatchewan contained crushed bone fragments from a young herbivore, proving T.rex consumed bone along with flesh. The coprolite was massive, about 17 inches long and full of phosphate from dissolved bone. Studying coprolites reveals diet details bones alone can't provide. What T.rex ate, how thoroughly it chewed, and how its digestive system processed food. It's humbling. Even waste becomes evidence. A mundane biological process turned into scientific treasure across millions of years. To die, Rex probably made vocalizations, though we can't know exactly what they sounded like. Its closest living relatives, birds and crocodiles, both vocalize, so it's reasonable to assume T.rex did too. Based on skull structure, it likely produced deep, resonant sounds, possibly low-frequency rumbles or roars. A 2016 study suggested large theropods might have made closed-mouth vocalizations, similar to how cassowaries produce deep, booming sounds today. Imagine a low, vibrating roar that you felt in your chest before you heard it. A sound that traveled through forests and made prey freeze. It wouldn't be less imposing, just different. Sometimes reality is quieter than fiction, but equally powerful in presence. 2. Rex fossils show evidence of healed injuries, suggesting a remarkable ability to survive trauma. Broken ribs, fractured tails, infected bones. All of these have been found in specimens that lived for years after the injury occurred. Healing requires time, which means injured T.rex had strategies to survive while impaired, perhaps scavenging, relying on stored fat, or hunting weaker prey. The body's ability to repair itself, even in a creature without modern medicine, speaks to the resilience evolution builds into living things. Pain was part of life, and survival meant enduring it. The teeth of T.rex were continuously replaced throughout its life, a process called polyphyodonty. Each tooth socket could produce multiple teeth over the dinosaur's lifetime, with new teeth growing in from below as old ones were lost or worn down. This ensured T.rex always had functional teeth for hunting and feeding. In contrast, mammals, including humans, only replaced teeth once. Dinosaurs had the advantage of perpetual renewal. Each lost tooth was temporary. The weapon repaired itself. Nature's solution to the problem of wear and tear. To stay, Rex may have engaged in intraspecific combat, fighting other T.rex over territory, mates, or dominance. Fossil evidence includes bite marks on skulls and bones that match T.rex tooth spacing and shape. Some specimens show partially healed bite wounds, meaning they survived the encounter. Others show fatal injuries. These battles would have been intense, two multi-ton predators biting at each other's faces and necks, using their massive jaws as weapons. Dominance came at a cost. The strongest won the right to reproduce, but even winners carried scars. The discovery of Jane, a T.rex specimen found in Montana, sparked debate over whether it was a juvenile T.rex or a separate, smaller species called Nanotyrannus. Most paleontologists now agree Jane was a young T.rex, around 11 years old, based on bone histology and growth patterns. However, the debate continues in some circles, with new studies occasionally reviving the Nanotyrannus hypothesis. As of 2025, the consensus leans toward Jane being a juvenile. This uncertainty reminds us that science is a conversation, not a finished book. To wear, Rex had extremely powerful neck muscles, necessary to support and manipulate its massive head. The skull alone could weigh 600 to 800 pounds. Lifting and twisting that weight required extraordinary muscle strength, visible in the large attachment points on the vertebrae. These muscles allowed T.rex to shake prey violently, tear flesh, and crush bones with its jaws. The neck was as much a weapon as the teeth. Modern Komodo dragons use similar head-shaking techniques to subdue prey. 2. Rex likely employed the same efficient methods. 2. Rex lived during a time of significant environmental change. Toward the end of the Cretaceous, volcanic activity increased, sea levels fluctuated, and climate began shifting. The western interior seaway was starting to recede, changing ecosystems and prey availability. These changes may have stressed dinosaur populations even before the asteroid impact. T.rex thrived despite these challenges, adapting to a changing world. But adaptation has limits. When the asteroid struck, environmental change happened too fast for any dinosaur to survive. Resilience has boundaries. The asteroid that ended the age of dinosaurs struck the Yucatan Peninsula in Mexico 66 million years ago, creating the Chicxulub crater. The impact released energy equivalent to billions of nuclear bombs, triggering wildfires, tsunamis, and a nuclear winter that blocked sunlight for years. Plants died, herbivores starved, predators, including T.rex, followed. Fossil evidence shows a sharp boundary in rock layers. Below it, dinosaurs. Above it, none. T.T. Rex disappeared within tens of thousands of years after impact. The age of giants ended not with a gradual decline, but with sudden, catastrophic extinction. You're still here with me, traveling through time and legend. Just notice where your mind is now. Are you thinking of T.rex walking through ancient forests, of bones sleeping beneath the earth? We're walking between worlds together. The world that was, the world that never was, and the world that is. All of them equally real in this drowsy space between waking and dreaming. Strange, beautiful, and perfectly calm. Let's continue our journey. After the asteroid impact, no land animal larger than about 55 pounds survived. T.rex, weighing 8 to 10 tons, had no chance. The sudden loss of sunlight meant plant death, which cascaded up the food chain. Small animals, burrowers, scavengers, generalists, survived in underground refuges. Large animals, with high caloric needs and specialized diets, perished. Birds, the descendants of small feathered dinosaurs, survived because they were small, adaptable, and could fly to find food. T.rex's size, once its greatest advantage, became its downfall. The world belonged to the small and flexible now. The first scientifically described T.rex fossil was discovered in 1902 by paleontologist Barnum Brown in Montana. Brown worked for the American Museum of Natural History and found partial skeletons over several years. In 1905, Henry Fairfield Osborn formally named the species Tyrannosaurus rex. The discovery captivated the public immediately. Here was a predator unlike anything living, a creature from deep time that challenged the imagination. Newspapers ran illustrations. Museums scrambled to find more. T.rex became the face of paleontology, and over a century later, it still is. Decrider. Rex existed closer in time to us than to Stegosaurus. Stegosaurus lived around 150 million years ago, during the Jurassic period. Rex lived 66 million years ago, near the end of the Cretaceous. That means 84 million years separated Stegosaurus and T.rex. More time than separates T.rex from modern humans. This perspective helps us grasp deep time's scale. Dinosaurs weren't a single era. They spanned over 180 million years, with ecosystems rising and falling, species appearing and vanishing. To growth, Rex came late to the story, a final chapter in the age of giants. Modern birds are direct descendants of theropod dinosaurs, the group that includes T.rex. While birds didn't descend from T.rex specifically, they share a common ancestor with tyrannosaurs. Features like hollow bones, ear sacs, and certain hip structures link birds to their dinosaur heritage. When you watch a chicken or a sparrow, you're looking at a living dinosaur lineage. The connection is real, written in bone structure and genetics. 27. Rex went extinct, but its cousins flew into the future, evolving into the 10,000 bird species alive today. In this way, dinosaurs never fully vanished. The brain of T.rex, though large for a dinosaur, was still relatively small compared to modern mammals. Its brain-to-body ratio was lower than that of primates or dolphins. However, size isn't everything. T.rex had specialized brain regions for vision, smell, and motor control, allowing it to be an effective predator without complex reasoning. Intelligence is contextual. A crow can solve puzzles a T.rex couldn't. But T.rex didn't need to. It needed to hunt, survive, and reproduce. It did all three successfully for millions of years. Evolution builds what's necessary, not what's excessive. Rex likely had a highly developed sense of taste. Taste receptors help animals identify nutritious food and avoid toxins. Carnivores today have taste preferences for certain types of meat and fat. To go, Rex probably did too, possibly preferring specific prey or parts of a carcass. Fossil evidence of selective feeding. Certain bones gnawed, others left intact, suggests T. Rex didn't just eat indiscriminately. It chose. Preference implies a level of sensory sophistication, a creature experiencing its meals, not just consuming fuel. Even predators had favorites. The Sioux T. Rex specimen revealed much about the species' health challenges. Sioux had infections, likely from parasitic organisms similar to modern Trichomonas, which affect birds of prey today. These parasites cause lesions in the jaw and throat, making eating painful. Sioux likely suffered, but survived long enough for the bones to show healing. This discovery connected ancient dinosaurs to modern diseases, showing that parasites and infections are ancient problems, not just modern ones. Life's struggles transcend time. Pain, illness, and recovery are universal. 2. Rex almost certainly couldn't roar like in the movies. Based on anatomical comparisons with living relatives, it likely produced deep, resonant, closed-mouth sounds, similar to the booming calls of cassowaries or the rumbling of crocodiles. Open-mouthed roaring, like a lion's, requires specific vocal anatomy that T.rex probably lacked. Instead, imagine a low-frequency vibration, a sound felt as much as heard, resonating through the forest. It wouldn't be less imposing, just different. Sometimes reality is quieter than fiction, but no less powerful. Some scientists propose T.rex may have had lips covering its teeth when its mouth was closed, similar to modern monitor lizards. This hypothesis, debated actively in 2022 and 2023, suggests that exposed teeth would dry out and become damaged without moisture protection. Lips would keep teeth hydrated and healthy. Artistic reconstructions now sometimes show T.rex with lips, changing its appearance from the exposed teeth movie version. We don't have definitive evidence either way, so both interpretations remain possible. Our image of T.rex continues evolving as science refines understanding. The discovery of soft tissue in T.rex fossils surprised the scientific community in unexpected ways. In 2005, paleontologist Mary Schweitzer found preserved blood vessels and proteins in a 68-million-year-old T.rex femur from Montana. This was thought impossible. Organic material shouldn't survive that long. Subsequent studies confirmed the findings, suggesting that under specific conditions, soft tissues can be preserved far longer than expected. This discovery opened new research avenues, allowing scientists to study ancient proteins and potentially extract genetic information. The impossible sometimes becomes real. Science rewrites its own rules. Pause here in the middle of our exploration. You've journeyed deep into the lost world. You've met T.rex, learned its truth, glimpsed its reality. Now just rest here, in this ancient forest of the imagination. No need to learn or remember, just experience. The air is warm, humid, filled with the scent of unfamiliar plants. Around you, creatures move, some you'd recognize, others utterly alien. You're safe here. This place holds you. Time includes you. Notice how your breathing has slowed, how your body feels heavier, how thought drifts like leaves falling through prehistoric air. We're halfway home. The rest of the journey is all downhill, all ease. Let's continue. To Tao. Rex lived during the final act of the Mesozoic era, the age of dinosaurs. It never knew what was coming. The asteroid struck without warning, a rock from space, ending an empire that had lasted 180 million years. Within weeks, the sky darkened. Within months, ecosystems collapsed. Within a few thousand years, every T.rex was gone. There was no preparation, no adaptation possible. Just sudden, total erasure. It reminds us that dominance is temporary. No matter how powerful, how perfectly adapted, how successful, everything ends. The fossils we find represent an infinitesimally small fraction of T.rex that lived. A 2021 study published in Science estimates perhaps 2.5 billion individual T.rex existed over the species' 2 to 3 million year lifespan. With about 20,000 alive at any given time, we've found maybe 100 individuals, counting partial skeletons. That means we've discovered approximately 1 out of every 80 million T.rex that ever lived. The rest vanished completely. Bodies scavenged, bones scattered, dissolved by time and weather. Every fossil is a miracle of preservation, a chance encounter between death and stone. The name Tyrant Lizard King carries weight across cultures. In English, it evokes medieval royalty, crowns, and thrones. In other languages, translations emphasize the predator's dominance. The Chinese name means ferocious dragon king, blending myth with science. In Japanese, it's overlord dragon. Names shape perception. By calling it a king, we anthropomorphize, project human hierarchies onto nature, signs. But T.rex wasn't cruel or noble. It was survival incarnate. Efficient, determined, and utterly indifferent to concepts of fairness. T.rex footprints, though rare, have been found preserved in stone. Each print tells a story where it walked, how fast, whether it was alone or with others. One trackway in New Mexico shows a large theropod, possibly T.rex, walking steadily across ancient mudflats. The depth and spacing suggest calm movement, not pursuit. It was just walking, existing. On an ordinary day 66 million years ago, that moment, unremarkable then, became eternal. Sometimes the mundane becomes monumental simply by surviving. T.rex didn't build, create art, or leave intentional marks beyond its bones. Unlike humans, whose civilizations leave layered evidence. Rex left only biological traces. Bones, teeth, footprints, fossilized dung. There are no T.rex structures, no tools, no symbols. Its legacy is purely physical, written in stone and interpreted by creatures that evolved millions of years later. This is the legacy of pure animality existence without reflection. Life without legacy building. Survival without story. And yet, we've given it a story anyway. If T.rex had survived the asteroid, would it have evolved into something even more formidable? Paleontologists speculate that given another few million years, tyrannosaurs might have developed even larger brains, more complex social behaviors, or specialized adaptations. But speculation is just that. Fiction dressed in science. The asteroid closed that evolutionary path forever. We'll never know what T.rex might have become. Sometimes potential remains forever unrealized, cut short by forces beyond control. Children around the world can name T.rex before they learn many other animals. It appears in books, movies, toys, museums. A cultural icon transcending borders. Why? Perhaps because it embodies primal fears and fascinations: size, power, teeth, extinction, or because it lived so long ago that it feels safe to admire, like a dragon that can never hurt us. Rex is humanity's favorite monster, loved precisely because it's gone. We celebrate it without risking anything. T.rex fossils are found in specific rock layers called the Hell Creek Formation and Lance Formation, dating to the latest Cretaceous period. Below these layers, older dinosaurs. Above them, the KPG boundary, a thin line of clay rich in iridium, evidence of the asteroid impact. Then, mammals and birds. The geological record is a timeline written in stone. Rex exists in one chapter, mammals in the next. The boundary between them is sudden, is violent, unmistakable. Some T.rex specimens show signs of cannibalism. Bite marks on bones match T.rex teeth, and the angles suggest attacks, not scavenging. Whether this was territorial violence, infanticide, or survival cannibalism during food scarcity, we can't know, but it shows T.rex was willing to kill its own kind. Apex predators often do. Dominance doesn't breed solidarity. It breeds competition, conflict, and sometimes consumption of rivals. Museums display T.rex skeletons in dynamic poses, mid-stride, jaws open, tail extended. These poses are artistic interpretations. The bones themselves are often incomplete, missing ribs, vertebrae, fragments. Paleontologists fill gaps with casts, educated guesses, comparisons to related species. What you see in a museum is part fossil, part sculpture, part science, part art. We reconstruct T.rex in poses we imagine, not necessarily how it died. Memory mixed with imagination. The study of T.rex continues evolving. New technologies, CT scanning, 3D modeling, protein sequencing, reveal details impossible to know a generation ago. Recent advances in high-resolution imaging have detected mineral traces in teeth that help determine seasonal diet variation across different life stages. Another analyzed bone microstructure to refine age estimates. Science doesn't finish studying T.rex. It keeps asking new questions. Every answer births more questions. Curiosity is endless. 1. Rex likely had a good memory for spatial navigation, able to remember territory, boundaries, and productive hunting areas. Large predators today, wolves, lions, orcas, have remarkable spatial memory. T.rex probably did too. This meant it knew its world intimately, where rivers ran, where herbivores gathered, which paths led where. It moved through its environment with familiarity, not randomness. Home was a map written in neural pathways, carried inside its skull. The climate T.rex lived in was warmer than today. Global temperatures were higher, sea levels were higher, and there were no polar ice caps. Forests extended far into the Arctic. T.rex lived in a greenhouse world, lush and humid. When the asteroid struck, the climate shifted violently, first superheating from impact, then freezing from ash-blocked sunlight. Rex evolved for warmth. Sudden cold was catastrophic. Climate change, sudden and extreme, has ended worlds before. No complete T.rex skeleton has ever been found. Every specimen is missing pieces. Sometimes just a few bones, sometimes most of the skeleton. Paleontologists piece together what T.rex looked like by combining data from multiple individuals. Sue is about 90% complete, making it extraordinarily valuable. Most specimens are far less complete. We reconstruct T.rex like a jigsaw puzzle with missing pieces, inferring what should be there based on related species and biological logic. 2. Rex had a relatively short neck compared to some theropods, but it was incredibly strong. Short necks provide leverage for powerful bites. Long necks, like those of sauropods, are for reaching vegetation, not fighting. T.rex's neck was built for violence. Short, thick, muscular, capable of absorbing the shock of bone-crushing bites. Everything about its body prioritized one function: hunting. Evolution had 70 million years to perfect the Tyrannosaur lineage. To time, Rex was the final masterpiece. Rex didn't live alone in its ecosystem. Smaller predators, like Dacotaraptor and Acaroraptor, hunted smaller prey. Herbivores of all sizes, Triceratops, Edmontosaurus, Ankylosaurus, smaller ornithopods, filled different ecological niches. Scavengers cleaned up remains. The late Cretaceous world was a functioning ecosystem, balanced like any today. The T.rex was the apex, but it relied on the entire web. Remove the base, and the top collapses. The asteroid removed the base. To endure, Rex may have migrated seasonally, following prey herds. Some herbivores, like Edmontosaurus, likely migrated to avoid harsh seasonal conditions, and T.rex might have followed. This is speculative. There's no direct evidence of T.rex migration, but it's consistent with modern predator behavior. Lions follow wildebeest migrations. Wolves follow caribou herds. If prey moved, Rex likely moved too. Home might have been a circuit, not a single territory. The bones of T.rex are among the most studied fossils in paleontology. Hundreds of scientific papers examine its anatomy, growth, biomechanics, ecology, and evolution. New studies appear regularly, each adding small pieces to our understanding. 2. Rex is the most famous dinosaur, partly because it's the most researched. Fame and knowledge feed each other. The more we study it, the more we want to know. The more we know, the more questions we generate. 2. Rex lived in a world without grass. Grasses didn't become common until after the extinction of the dinosaurs. The late Cretaceous landscape was dominated by ferns, conifers, flowering plants, and cycads. The ground cover looked nothing like modern plains or meadows. Imagine forests without grass, rivers without grasslands, only primitive flowering plants and ancient ferns carpeting the earth. 2. Rex walked through an alien world, beautiful and strange. Some T. Rex specimens show evidence of infections caused by bacteria or parasites, lesions in bones, cavities in skulls, signs of abscesses, all documented in fossils. These infections sometimes healed, sometimes they didn't. Imagine T. Rex living with chronic pain, a deep infection in its jaw, unable to eat comfortably, but unable to stop. Life doesn't pause for illness. Survival means enduring pain, functioning despite damage, pressing forward because there's no other choice. The closest living relatives of T. Rex are birds, specifically chickens and ostriches. Genetic and anatomical studies place tyrannosaurs within Coelurosauria, the same group that gave rise to birds. This doesn't mean T. Rex was a bird, but it means birds and T. Rex share a relatively recent common ancestor, geologically speaking. When you eat chicken, you're consuming a distant cousin of the most formidable predator that ever walked the earth. Evolution has a sense of irony. 2. Rex likely had complex social behaviors, though evidence is limited. Some theropods show signs of pack behavior, but T. Rex evidence is ambiguous. Most fossils are solitary individuals. However, the presence of healed wounds from intraspecific combat suggests T. Rex at least encountered others of its kind regularly. Whether they hunted together, competed violently, or simply tolerated each other in overlapping territories remains debated. Solitude or society, we may never know which defined their lives. The discovery of feathered dinosaurs in China in the 1990s revolutionized our understanding of theropods. Close relatives of T. Rex, like Utyrannus, had extensive feather coats. This raised the question, did T. Rex have feathers too? Current evidence suggests adult T. Rex were mostly scaled, possibly with some protofeathers on parts of the body. Juveniles might have been fuzzier. The image of T. Rex keeps shifting, from scaly monster to something more bird-like, more nuanced. Science refines, but never finishes. The picture. To die, Rex was not the largest carnivorous dinosaur. Spinosaurus and Giganotosaurus were larger, though they lived in different times and places. T. Rex was, however, the most powerfully built. Its bite force exceeded all known terrestrial predators. Size isn't everything. Power and efficiency matter more. To eat, Rex was optimized for its environment, its prey, its time. In its world, it was unmatched. That's what apex means. Not biggest, but best adapted. When the last T.rex died, there was no ceremony, no awareness of the end. It likely died alone, perhaps from starvation as ecosystems collapsed post-impact, perhaps from injury or disease. Its body was scavenged or decayed, bones scattered. There was no final roar, no dramatic last stand, just quiet extinction, one individual at a time, until none remained. The end of a species is often silent. The world moves on. Grass grows. New creatures fill the empty spaces. You might be feeling tired now. That's exactly right. Breathe slowly and think about cycles. Animals live in cycles, day and night. Season and season. Life and death and life again. Species rise and fall like tides. Dinosaurs ruled for 165 million years, then vanished in an instant. Mammals rose from their ashes. Everything ends. Everything begins again. The circle is unbroken. T.rex is gone, but the Earth continues turning. New creatures evolve, adapt, thrive, and eventually vanish. The cycle is eternal, indifferent, beautiful in its relentlessness. You are also part of these natural rhythms. Your body knows them: the cycle of breath, the cycle of waking and sleeping, the cycle of energy rising and falling. You don't need to fight the tide. Just let it carry you. Like ancient creatures sinking into stone. You can settle too. We're almost there now. Almost home. T.rex bones lie in museums on every continent. Children press faces to glass, tracing the outline of teeth, imagining the creature alive. In those moments, T.rex exists again. Not in body, but in wonder. Each visitor reconstructs it in imagination, brings it to life briefly, then lets it fade. We resurrect T.rex over and over, not in flesh, but in thought. Memory is a form of immortality. The name T.rex appears in movies, books, songs, toys. It's become more than a dinosaur. It's a symbol, strength, extinction, primal fear, childhood wonder. Different cultures see different things in it, but all see something meaningful. A Chinese child and an American child both know T.rex. It transcends language. Some creatures become myths even when they're real. If you could travel back 67 million years and see T.rex alive, it would probably disappoint and fascinate in equal measure. Reality is never as dramatic as movies, and yet undeniably real. Warm, breathing, smelling of musk and decay, watching you with eyes that see, sighs, even expected, overwhelms in person. A living T.rex would be quieter, slower, stranger than imagined. T.rex likely experienced emotions: fear, aggression, contentment. Brain structure suggests basic emotional responses, similar to modern reptiles and birds. It felt hunger sharply, satisfaction after feeding, pain from injuries. Whether it felt anything like love or grief is unknowable. But it wasn't an emotionless machine. It was alive. And life includes feeling. Even monsters have inner worlds. the asteroid that killed T.rex also killed 75% of all species on Earth. But it didn't kill life itself. Within 10,000 years, ecosystems began recovering. Within 1 million years, new species evolved to fill empty niches. Within 10 million years, mammals radiated into forms that eventually became us. T.rex's extinction made space for humanity's distant ancestors. One ending enabled another beginning. Some nights, under stars in the Badlands of Montana, paleontologists camp near dig sites. They sleep on ground that holds bones of creatures who once looked at the same stars. The constellations have shifted slightly in 66 million years, but the stars remain. T.rex saw the Milky Way, felt wind, heard silence. We share the same sky, separated only by time. 66 million years separate us from T.rex, an unimaginable gulf of time. Yet through fossilized bones and careful study, we've learned to see across that distance, reconstructing lives lived in a world utterly different from our own. We exist in separate chapters of Earth's story, but knowledge is a bridge. Connection across time doesn't require presence. Children draw T.rex with crayons, big teeth and tiny arms, fierce and lovable. Adults make films where it chases jeeps, roars at cameras. Scientists publish papers refining jaw mechanics. All of us, in our ways, keep T.rex alive. It survives in culture, not biology, in imagination, not flesh. This is a different kind of existence, but existence nonetheless. The bones we find are just calcium and minerals. The original material replaced molecule by molecule by stone. What we call a T.rex fossil is technically rock-shaped like a bone. The creature itself is entirely gone. Every cell, every protein, every molecule of flesh. Only the shape remains. A shadow cast in stone. We mourn shadows. If T.rex could know, it's remembered. Would it care? Probably not. It had no concept of legacy, no awareness of time beyond its own life. Fame is a human obsession. To T.rex simply was. Lived, hunted, reproduced, died. We're the ones who built monuments, who wrote its name in textbooks, who ensured it wouldn't be forgotten. We remember because we need to. In the final days, T.rex simply lived ordinary lives. They hunted, felt ordinary hunger, walked familiar ground. The last one had no idea it was the last. Endings are only visible from outside. From within, every day is just another day. There was no farewell, no awareness that the world was changing forever. In museums, T.rex skeletons are lit dramatically. Spotlights casting shadows on walls. Children whisper. Adults pause. There's something about standing near those bones. A recognition of scale, of time, of mortality. We look at T.rex and see our own fragility reflected. If something that powerful could vanish, so can we. Humility, written in fossil bone. T.rex footprints, when found, are treated reverently. Each print is a moment preserved, a step taken 66 million years ago, now frozen forever. Imagine you walk across mud, The mud hardens. Sediment buries it. Millions of years pass. Someone digs it up, sees your footprint, and knows you existed. That's what we do for T.rex. We witness its footsteps. Some scientists dedicate entire careers to T.rex. Decades spent studying bones, writing papers, debating details of biomechanics or growth rates. Why? Because understanding T.rex means understanding evolution, extinction, the mechanics of life. It's a puzzle complex enough to fill lifetimes. And maybe because it's beautiful, in its way, dedicating life to honoring something long dead. T.rex lived in a world governed only by biology and physics, without human complexity. That world is gone. Our world has replaced it. But bones remain, tangible proof that Earth once belonged to others. We're temporary tenants, not permanent owners. Today, Rex reminds us of that truth. The Hell Creek Formation erodes slowly, revealing new fossils every year. Rain and wind strip away sediment, exposing bones hidden for millions of years. Paleontologists return annually, hoping to find what last year's storms uncovered. Why? Rex still emerges from stone, one fragment at a time. The Earth gives up its dead slowly, reluctantly. Patience is rewarded. If you hold a T.rex tooth, you hold something 66 million years old. It rested in jaws that bit through bone, tasted blood, felt the struggle of dying prey. That tooth outlasted its owner by incomprehensible time. It's older than mountains, older than most of Earth's current surface features, and yet it's small enough to fit in your palm. Time made tangible. Some people visit T.rex skeletons repeatedly, like visiting old friends. They notice details missed before. A crack in a rib, the angle of a claw, how light hits bone. Familiarity breeds not contempt, but deepening appreciation. T.rex becomes personal, not just a scientific specimen. We form relationships with the dead, across impossible distance. Rex has inspired countless careers. Paleontologists cite childhood visits to museums, seeing T.rex for the first time as the moment they knew. One creature sparked lifetimes of scientific pursuit. This is legacy too, not biological, but intellectual. T.rex shaped human knowledge, human curiosity, human wonder. It changed us without knowing we'd ever exist. The extinction of T.rex was sudden, but fossilization is rare. Most animals die and decay completely, leaving nothing. For every T.rex fossil found, millions lived and vanished without trace. We remember the minority, the lucky few whose deaths occurred in conditions perfect for preservation. Most T.rex are utterly gone. We study the exceptions, the miracles. In the deep future, millions of years from now, will something find our fossils and wonder about us? Will they reconstruct our lives from bones, debate our intelligence, make movies about us, or will we vanish completely? Too fragile to fossilize T.rex had bones built to last. Ours are smaller, weaker. Maybe we'll be forgotten while T.rex remains remembered. to go now. Rex teaches us that dominance is temporary. For 2 million years, it was unmatched. Then, gone. Nothing lasts forever. Not species. Not empires. Not even planets. This isn't sad. It's just truth. Impermanence gives life urgency. If T.rex lasted forever, would it matter? Because it ended. It's precious. We cherish what we lose. The earth keeps spinning. Seasons change. Life continues. T.rex is gone. But forests grow where it walked. Rivers flow through valleys it knew. The planet heals, regenerates, forgets. Only humans remember, keeping the past alive through choice, not necessity. We could forget. We choose not to. That choice is meaningful. When you close your eyes tonight and think of T.rex, you resurrect it briefly in the theater of your mind. It walks again, hunts again, lives again in imagination. This is the closest thing to time travel we have. Reaching back through memory and knowledge, pulling the past into the present for a moment, then releasing it, letting it sleep. Today, Rex is gone. Completely, utterly, irrevocably gone. And yet it's here with us tonight. In words, in thoughts, in the quiet wonder of knowing something that once was. We bridge the impossible gap between then and now through story, through science, through the refusal to let the past vanish entirely. T.rex lives in the space between forgetting and remembering. And as long as we tell its story, it survives, not in flesh, but in echo. The tyrant lizard king sleeps in stone, dreaming the dream we dream for it. And so, our journey through time and legend comes to a gentle close. We've walked with giants, from T.rex hatchlings the size of turkeys, to adolescents racing through ancient forests, to adults powerful beyond imagination. We've traced the arc of a species that dominated its world, then vanished. From the moment T.rex opened its eyes in a Cretaceous nest, to the final individual's last breath beneath a darkening sky, we've witnessed the rise and fall of the tyrant lizard king. We've honored creatures that lived, creatures that never lived, and the truth that both shape who we are, reminding us that to remember is a form of love. Extinct animals remind us that love outlasts death. Much of what we cherish exists only in memory now. Species we lost, stones that were once alive, all living on in the space between history and dream. T.rex teaches us that endings are real, and so our choices matter. Without remembering what's gone, we risk losing what remains. Without imagining what never was, we lose our capacity for hope. By honoring both the lost and the legendary, we become better guardians of the living, better dreamers of possible futures. In these final moments, take the deepest breath you can. Think about connection. Every animal, past, present, extinct, mythical, real, connected through the web of life on Earth. The creatures we remembered tonight, some lost forever, some never real, all living on in memory, story, and dream. Extinction teaches us impermanence. Myth teaches us imagination. Together, They teach us that what we lose and what we create are both forms of love. Let your entire being dissolve into the ocean of time, into the space where past and future meet, into the eternal present where all creatures, real, extinct, imagined, exist together in the boundless landscape of the mind. Prepare for deep sleep. No boundaries left between you and rest. Only peace. Only breath. Only the soft darkness welcoming you home. If this journey through time and legend helped you feel connected to something larger than yourself, consider sharing it with someone who loves both science and story. A gentle like and subscribe helps other curious minds discover this space where memory and wonder meet. One quiet moment, one sleepy soul, one story at a time. But there's no need to do anything now. Nothing at all. You've journeyed far tonight through time, memory, and imagination. You can allow these thoughts of lost and legendary creatures to fade now, like ancient footprints covered by time, leaving only the warm knowledge that you witnessed their stories. Let your breathing deepen. Let your body feel heavier, like settling into the layers of history itself, resting on the bones of extinct giants, dreaming the dreams of creatures that never were. If sleep comes, let it carry you across the boundary where the real and the imagined meet, smoothly, inevitably, into the space where mammoths walk through forests and T.rex hunts beneath stars. If your eyes are still open, more stories wait. But if they're closed, stay there. Stay in that timeless place where past, present, and future blur together, where every creature that ever was or might be exists in the eternal now of dreams. Tomorrow, fossils will still rest in stone. Stories will still be told. New creatures will still be imagined. But tonight, you rest in the company of all beings, real and mythical. Whoever sought peace in sleep, sleep well, time traveler, and remember, memory is a form of love, and imagination is a form of hope. Dream deeper with creatures of the earth. Good night.